Hey guys, let's go to the lesson that we're on. This is lesson 9. So it's on page 431. Please go there. Okay, sorry, I'll put this screen up right away here. Okay, here we go. Okay, so it's lesson 9. You're solving problems involving rationals. Okay, and you're typically going to have your basic physics formulas for constant velocity. You guys can see it okay? Okay, so guideline for solving problems involved in this unit for this course. The big one is reading the problem carefully. That's almost true in any course. Just read it carefully. And what you're going to have to do is introduce variables. And what you're going to need is an algebraic equation that's in rational form. Okay. So let's try to do this. They're going to give us a chart to help. This pyramid is a teaching tool. Basically, I like to use units better. I prefer to use units. So like kilometers per hour, what do you guys think about when I say kilometers per hour? Kilometers per hour, what do you guys think? Speed, right? Okay. So velocity is represented in kilometers per hour. So displacement over time. Okay. Just for like, since we're not in physics class, we can just call this speed, distance, and time. Okay. So the speed can be expressed as a rational equation. Does that make sense? The speed is irrational. Okay. Is there another way to rearrange this so it stays as a rational? How to do that? Move the t and switch with the v. So t equals d over v. Now let's think about the units for t equals d over v. What would the units be for distance? Yeah, we can do, let's just do kilometers and hours. So kilometer. And then what's speed in going to be? Kilometers per hour. So what do you notice happening? The kilometers cancel, and then you have a divide hours. So that means hours comes to the top, and you're of course in time. Okay, so let me just jot those down one more time for you. V equals d over t, and think to yourself kilometers per hour. Oh, that's ugly. So think to yourself kilometers per hour. And the other one will be t equals d over v. And this would be kilometers divided by kilometers per hour. So the kilometers cancels and the hours come up. So it's a little bit of a review from, say, like a Science 10 or maybe even like a Physics 20. Science 10 for the most part, though. And what's the other one we haven't solved for? The distance, yeah. And this one's going to be non-rational, and this one's actually linear. D equals vt. So it's not rational. And typically you will not see these ones. In this unit, in this section, because it's not rational. Yeah, in a physics course, of course, yeah. But in this course, with this unit, this lesson in particular, we're typically going to have a rational, because that's the unit we're in. Okay, so let's start with this first one. Let's read it carefully. That's the big thing here. You're going to have to highlight the important stuff. That's the most important thing. Okay, so crossing out what does not matter. Okay, so she cycles for 120 kilometers. I just like to put the letter of the variable next to it. Okay, and then she swims for another 12 kilometers. So we have two distances. Let's call them D1 and D2. You guys okay with that? So what we're doing, Joel, is we're introducing variables to model the problem, which is one of the hardest things you guys have to do when you're learning math and science growing up, is modeling a problem with variables. That's tough to do because you have to be creative and you have to think. It's not just like repeating an algorithm or something, or just doing a method. You actually have to try this on your own and think. So anyways, it says her average speed. Now, in physics, these kids know about this, but for you guys, like, average speed is just going to be the formula for speed. This is the formula for v. It's the formula for v. That's what they want. Average speed. So that is d over t. So that's what you're looking for when they say average speed. So when they say average speed, just think speed. And it says it was 8 times faster than her average swimming speed. Does that make sense? When you ride a bike, typically are you going faster than if you're swimming in a lake or something? Yeah. So let's just cross out that S down there. I don't like that they're using S. Use V here. And then cycling would be 8V. And I'll highlight how we came to determine that. Her average cycling speed was 8 times faster than her average swimming speed. That's this information put in this chart here. Now, if you want to build a chart on your test, that's up to you. Okay? I typically don't use a chart. I just create the rational and then solve it. Okay? So what we did is we assigned the letter V to the swimming speed because cycling is 8 times that. So it makes sense to write it like this. Then it says Shannon took 9 hours to complete the race. So don't do this. Don't do this. Did some of you do that? No. It would make more sense if it was something like this. Why? It takes longer to swim. Now we don't know what they are individually. Okay? But what we can do is we can create a rational expression. What do we know for the distance? The distance for the cycle, what is it? 120. And what's the distance for the swim? 12. Now, using the expression for time, which I have up here at the top, what's the formula for time? D over V. So this is D, this is V. So do D over V for time. So for the first one, 120 over 8V. Excuse me. Excuse me. And the other one, what's the other one going to be? 12 over V. Now, if we knew what V was, would we be done? Yeah. Okay. So it says for part A, if her average swimming speed is S, which was V, we change that to V, so just switch that to V. Use the information to complete the table. Okay, we did that. Now it says calculate her average swimming speed. So what do we know about the time to cycle and the time to swim? What does it say about the time? What does it say here? And it equals 9. What equals 9? The time for what? The time for cycle and what else? And the time for swim, right? Is that all the 2 activities she's done? So the time for each has to be 9. Remember I said it might be 3 and 6, could be 5 and 8, could be 1 and 8, could be 2 and 7, right? It was an accident. Excuse me, Emily. What's on that that's so much more important than me? Let's just give Emily a little lesson. Everywhere, every day, not constantly filling with phones. Is that you? At all times it is permissible to sit, observe, and actively listen to the poetry of my instruction. The arrival of a snippet of trivial text does not hold the promise of unimagined pleasure.
I've never read that before.
Don't look at that phone. All that phone's going to bring you is probably stress. It's like, what's today's drama? You know what I mean? Okay, so what's the formula for the time for the cycle? 120 over 8v. And what's the time for the swim? 12 over v. And what do we know this has to equal? 9. 9 hours, and our formula for time is in kilometers per hour, so this should work out. So everything's in kilometers an hour, so this should work out. So how do we solve this? You did it on your quiz. We can't cross multiply. When can you cross multiply? When it's one term on each side. No, they have to have a common denominator to add them together. So the strategy that I gave you was just multiply everything by LCM. What Shaq is saying is, why don't I just put an 8 here and an 8 here and then add them? Which is a wicked strategy. I really like that. Okay, but I'm not going to show that because that's not what I've been teaching. No, that's amazing, Shakeem. I like that you did that. So what the book says is just to multiply everything by the LCM. And what is the LCM? 8v. Which is exactly what Shaq said. Just put an 8 there and an 8 there. Okay, so let's multiply everything by 8v. So 8v. Okay, so 8v is going to get distributed in. And 8v is just getting multiplied here. So on the right, you have 72v. And on the left, what's happening? What's happening on the left? On the first one? Yeah. So on the first one, you just get 120. But what happens on the second one? I am. 8v comes in on the first one, and 8v cancels with the denominator, and you're left with 120. Now it's coming in on the second term. And only what cancels? Only the v. So you have 8 and 12 up top. Okay, so what's 120 plus 8 times 12? 216 equals 72v. Divide by 72 and you get 3. Okay, so what's her average swim speed? 3 kilometers per hour for the swim, and for the cycle it would be 3 times 8, which is 24 kilometers an hour for the cycle. You guys okay with that? Oh, the cycle is 8 times the swim speed. So I just took her swim speed and times by 8. No, that's nothing special about that. Okay, so flip the page and I want you guys to try assignment question number 1. Okay, we'll do number 2 together, but I want you to try assignment question number 1. Okay, I'm going to pause the video and see if you guys can try this. Please highlight the important information. Okay, so we came up with this, and somebody help me solve this. What do I do? Cross multiplying, we got 329x equals 308x plus 6. Distributing the 308. And help me out with 308 times 6. All right. Now how to solve this linear equation. Put 308 to the other side with subtraction. What does that leave? 21? You almost did it, McKenna. You said 21. She did. I heard it. So dividing by 21, what are we getting for this speed for Evan? 88? Okay. So then do Megan, x plus 6, 88 plus 6. 94? Have we even answered the question? What does it say? Calculate her average. Ooh, I forgot to highlight something. And the time. So always reread the question, see if you did it properly. Calculate her average speed. So that's Megan. We have that. And the time taken for the journey. So just put in x right there, and you'll get the time. 308 over 88. 3.5 hours. Very nice, you guys. Would you like to try another one? You want me to do class example 2? You guys want to try one? Okay, so one that's similar to that is number 6. Okay, so why don't you guys try number 6? That one's very similar. I'll pause the video. You guys try number 6. Okay, so I just unpaused the video and we were able to generate this as a class. Just made some notes about current, upstream versus downstream. We're in the middle of cross multiplying and solving, so 12v minus 8v is 4v. 48 plus 72 is 120. Dividing by 4, we have 30. All right. Have we answered the question? What does this say? Write expressions for the speed of the boat traveling upstream and downstream. So going upstream, it's 30 minus 6, and downstream is 30 plus 6, so 24 and 36. What unit is this? Kilometer per hour? Then it says calculate the time it takes for the boats to travel upstream. So you could do either one because it's going to be the same time. But let's just use the upstream formula. 8 over v minus 6. Eight over 24. This is not the right time. We have to read this properly. What is it saying? Calculate the time for the small boats to travel from the cruise ship to the port. See how it's like reading carefully matters so much? What do we use 18 for? And it's part B, yeah. Like why did you probably highlighted this and you haven't used it yet? Yeah, that's the distance from the cruise ship to the port, and that's what they want. So they're looking for you to solve for time, which is d over v. D is 18 and v is... Yeah, so they gave you two different distances and said it takes the same time for that to happen. You're able to calculate the speed from that and then go back and solve the original question. So 0.75 of an hour or 45 minutes. Question? I can answer that shortly. Let's do class example 2. Okay, class example 2. Again, let's highlight the key information so we don't make mistakes. I'm looking at this. The council's traveling from 2 towns. Don't care. The travel budget says we have 2 options. Okay, whoop-de-doo. So here are the 2 options. They can leave tonight by bus, or they can save 3 hours by leaving tomorrow morning and using the express train. So which one's faster, bus or train? So train's faster. And how much time are you going to save? 3 hours. Okay. So if let's say the bus was 6 hours to get there, how much would you get there on the train? They can save 3 hours. So if the bus took 6 hours, how much would the train be? 3 hours, right? What if the bus was 7 hours? Yeah, 7 hours and then 4 hours. So sometimes it almost helps to just like play with some numbers and see what the relationship is. So what do you see here? What's the relationship? The time for the bus and the time for the train. What's the relationship? You need to have some equation. If you minus them, you always get 3. So that's difficult. Do you agree? I mean, once you've seen it, it's like, oh, I get it. Coming up with it on your own, that's challenging. And like, you can save 3 hours. Like, what does that even mean? Save 3. That's why I like just play with it. Just try some numbers. Play with it. See what it looks like. Try to brainstorm. Okay, what's the formula for time? Done this lots now. So it's d over v for the bus minus d over v for the train. Okay, so what's the it's got to be the same distance, right? They're both going the same place. So what's the total distance we're going? 1,500. Okay, put that in. And then all we have to think about now is the speeds. Okay, so put in the values for the distance, and now all we have to do is think about the speeds. 1,500 over equals 3. All right, what's the speeds? Which one's faster? So let's call bus X, bus speed X. And that must mean if this one's faster, it would have to be what? X plus 25, good. That's what you meant, right? Yeah. Okay, so time for bus, time for train. We're subtracting them and we're going to get 3. See how that was built? I didn't even need the chart that time. Now what do I multiply in by? LCM, which is what? X plus 25. Put it here, X plus 25. Now I'm doing that distribution without really even showing it because I'm just getting good at this now. On the left-hand side, the x cancels on the first term, and the x plus 25 cancels on the second term. Now I'm just going to write a little bit smaller. So 1,500 x plus 25 minus 1,500x equals, and I got 3x x plus 25. And at this point, it's just distributing and collecting. So So I'm just going to go through this. 1500 x plus, thank you, she said 37,500 minus 1500x equals 3x squared plus 75x. What's happening on the left there? The 1500x's are canceling as a zero pair. So what should I do? I got a what kind of a polynomial here? You get the quadratic, right? It's not linear. Those other ones we did were linear. This one's quadratic. So how to solve quadratics? Make it 0. Good. So let's put that 37.5 on the other side. Now we have 0 on the left. And how to solve that guy? Can I factor it? Well, just double check. I know 75 divides by 3, but does 37,500 divide by 3? It does, eh? So let's take out a 3, and you get x squared plus 75x. What was it? 12,500. Now, can this guy be factored? Like 12.5, like that's crazy, right? What are the numbers that multiply to 12,500? Yes, you can use quad formula. How'd you find that so fast? So what would I would do? I would start with 12.5, 0, 0 in my calculator, and I would divide by 2. Not even close. So now I try a bigger number. I would divide by 5. Not even close. It's not even close to getting to 25. So now I'm going to try a bigger number. So I'll try 25. 25, I got 500. So I'm getting closer. You can use 100. And then you found it, right? It's a 125 and 100, and which one's negative? 100. That's a tough polynomial to factor. What's a good strategy for this? Put this in your calculator and go and find the 0. So it's going to tell you it's 100, and then you know that the factor is x minus 100. Okay? So what are the two answers for these factors? And x equals. And what is the x value? What are we doing? It can't be negative. Why? What does x represent? The speed. And speed is a magnitude only. It can't be negative. So speed can't be negative.
So you're doing that actually physics and math together, right?
Yeah, there's some cross-curricular here for sure. Especially the quadratics unit. But the physics kids aren't all the math kids. It's weird.
It is weird.
It's weird, right?
Should be.
They should be, yeah. Like all the kids who take physics 20 should all be taking math 20-1 at the same time, I think.
Exact same time.
Well, like, it makes sense if you're going through, like, the same thing. Yeah.
Right? Not, it's terrible because now what do you got?
It's nice that you've taken 20-1 before physics 20. That's nice. Some people take physics 20 before 20-1, and that's not good. Because then you don't understand the trig, and you don't understand the quadratics. Yeah. Okay, so we're rejecting this. What do we call that again? It's extra. Good. And that means x is 100. Have we answered the question? How long would it take to travel by train? That's what it wants. So to travel by train, how long? That's this one, right? So we need this one. 1,500 divided by, what's the velocity or the speed of the train? X plus 25, right? Speed of the train, x plus 25, so 125 here. That answers the question. 1,500 divided by 125. 12 hours. Challenging questions? Probably, this is probably one of the hardest lessons in the 20-1 unit. Let me look at the test.
I'm sorry for the placement exam. Yeah.
So, guys, one written response from this unit. 3 marks. Guys, the written response for this test has 12 marks. So 5 questions, 12 marks. And 3 of the marks come from a question like this. 1 question in the written response. But there'll be some in the multiple choice. I'm seeing 2 in the multiple choice. Yep. So 5 marks. 5 marks out of 27. So roughly a fifth of the test is on this unit. So 20% of your mark is coming from this lesson. So you can't just you can't just forget this lesson, because then you can only guarantee yourself at 80% if you do everything correctly. Right? So you're going to have to study this lesson. My recommendation is that you try number 2 and number 2 for sure. And then the rest of them are a little bit different. But I like number 9 as well. 2, 9, 10, 11. And then if you can do the other ones, then that's amazing as well.